Hey guys, welcome back everybody. So
Uh,
we have covered let me make everyone mute.
Good morning, sir.
Hey, good evening, good morning. So what we have covered the VLAN. So I hope you understand the VLAN very good, in a good way, right? So we have covered in the VLAN, we have covered the BTP protocol, we have covered the trunking protocol, right? And we have seen that in a trunking protocol 80.1q, right? Also, we have covered the DTP protocol, and also we have seen the multiple use case of the command line, right? Like a switch port mode access and switch port access VLAN, how to disable the DTP protocol on the access port and how to disable the DTP protocol on the trunk port. At the same time, right, we have also covered that how you can filter the VLAN on the trunk interface. So there is a two ways. One is called the dynamic approach known as a BTP pruning, and second way is it's called as a BTP, switch port trunk allowed VLAN. So that you can do the manually. Then after that, I'm sorry. Then after that, we have also covered the concept of private VLAN, VACL, and the protected board. So based on these things, right, you can manage your VLAN in your network. For example, if you want to provide the security in your network, so you can do the VACL and protected board. And private VLAN concept comes in the picture when you are when you have a limitation of the VLAN. If you feel that there's a scalability of the VLAN, then you can do the private VLAN in your network. Mostly the service provider are used to configure the private VLAN for the customer side. And then after that, yesterday we have covered the IVR concept, right? Inter-VLAN routing. So we have seen the three ways, right, to do the inter-VLAN routing. The first way we have seen that you can make a router over there. Oh, why it's not working? Hold on. Okay, so what we have covered the inter-VLAN routing. So we took the example of the router one, and then we took the two interfaces, right? We have a switch one, and where we have a VLAN number 10 and we have a VLAN number 20 users over there. So in that case, what happened? This interface can belong to VLAN number 10, this interface can belong to VLAN number 20, and you can achieve the communication between the two different VLAN. Second way is that this is the first approach. Second approach, we have seen that's called the router agnostic. So you have a switch one, right? And then we have a PC number 10 or PC 20 over there, VLAN number 10 and 20. In that case, what happened? You need to split this physical interface into the two sub interfaces. So you can call as 0/0 and 0/0.20, right? So you can create the sub interface, and based on that, you can do the inter-VLAN routing as well. Make sure that this interface should be trunk interface. It doesn't require over here. The third way is that we have seen that you have a layer 3 switch, right? And the layer 3 switch can provide the inter-VLAN routing as well as the VLAN number 20 and 1020 is there. So you need to get the SPI for the 10 and you need to get the SPI for the 20, right? And then you can achieve the inter-VLAN routing. So the major problem of this guy is what someone has asked this question in the group, right? So the major problem of this one is what? It's a single link failure. So if this link goes down, you don't have a backup one. That's a major issue. So the problem of this guy is what? Cost, right? The problem of this guy is what? Single link failure. So it's depend on the requirement. Like it's depend on the scenario, how you are gonna deploy the inter-VLAN routing. Now, the next topic, right? It's called as a spanning tree protocol. Before I'm gonna start this topic, right? Before I'm gonna start this topic, let me introduce the first thing, right? What is loop?
Sir, I'm sorry to interrupt. You have a little question about the previous
Yeah,
class yesterday
yeah,
in regards to the interview routing. I understand you subdivided the interface into
sub
the two
interface,
different VLAN.
right?
Yeah, dot 10, dot 20. So
Right.
what you have done, you configured the both VLANs between the switch and the router, right?
Yeah. So on this particular
On
interface, I got the VLAN number 10. On this particular interface, I've got the VLAN number 20 over there. And on this side, on the 0/0, we are just splitting the interface into 10 and 20. And then here we need to call the encapsulation dot 1q to VLAN number 10 and encapsulation dot 1q VLAN number 20, so that tagging will be possible.
No, yeah, no, that is absolutely fine. I understood that. My only confusion was that between the switch and the router.
Mhm.
So when you have subdivided the inter VLANs, sorry, the VLANs into the two parts, into the both different links.
Okay.
So where did you actually configure the default gateway?
The default gateway, the IP address of this interface will be the default gateway for the VLAN number 10. The IP address of this interface will be the default gateway for the VLAN number 20.
Okay, so
default gateway
basically,
default gateway you're going to configure on the PC side, right? On the PC side. But which IP address? The IP address of this interface.
okay, so you have configured the default gateway on the both PCs, right? But on the router link, there are two links. One is on the switch side, one is on the router side. On the switch side, I understand you have configured the .10, and the other side you had configured the .1.
No, not
But
on the
what
switch
about
side. On the switch side, we have configured the trunk, this interface.
Okay, I see. Yeah, sorry, I got it. I'm sorry. Yes, you have configured trunk, but those subdivision of the VLANs you have configured on the router link, right?
Only on the router link, right?
Okay, that's fine. That was a little bit.
This is the layer 2 interface. This trunk interface has the ability to carry all the VLAN traffic. You cannot configure the trunking on this particular side, right? Because the trunk is a part of the layer 2, not the layer 3.
Yeah, that's right. Yeah. Okay. So once you have configured that, then you done the trunking. Then on the router side, then you did the inter VLAN, right?
Right, on the router side, we did the inter-VLAN routing. Encapsulation.1q is a layer 2 protocol. Then how the router will understand the encapsulation.1q, then this command. So we are just giving the command to this router side, right? They are not understanding the protocol for this side. We are just splitting the interface. No, Nisar has asked the question in the group. So we are just giving the command on the router interface, right? Okay, the command is acceptable, but they will not understand the protocol.
Okay, so basically you did the switching, then you did you configured the trunk interface, then you done the inter VLAN routing, and that's it.
Right,
By doing all this, then the PC1 will be able to communicate to the PC2. That's the whole scenario.
That's whole scenario, right?
Okay, great. That's fine. Thank you so much. Cheers.
Now, so before I'm going to start the spanning tree protocol, guys, first I'll let you know what is loop. Can anyone define me what is loop? Anyone has an answer of what is loop?
Yeah, loop basically when there is for example, if there are three pieces, for example, or
Forget
three
the PC
links.
right now. I'm talking about the real life scenario. What is loop?
Yeah, I mean loops actually when there's a flooding in networks,
Forget
to avoid the flooding.
Forget the network
Loop
right
is
now.
checking for internet connect. The network connection connectivity.
Doing the
No,
same
so
thing.
I think loop is basically in simple words a cycle or a circle when something keeps happening around and around without ending.
Yeah. That they're
without
doing the
any
same thing, right? That's
endpoint.
the good answer from the Nisa, right? It's saying they're doing the same thing. That's correct thing.
That's right. Yeah. That's actually a good answer. Yeah.
Same thing. That's called as a loop. How? Let's take example. Infinity way, great. But some loop is not infinity. So take example. So there's a guy, right, at the Bangalore airport. Okay, so there's a guy on the Bangalore airport. So he started the journey, and the destination source is the Bangalore airport right now. The destination is what? He wants to reach to the maybe HSR layout. Okay. And but unfortunately, what happened? He started the car from there, right? And after some time, right, after 2 and 3 hours, because Bangalore is a lots of traffic, he reached to the same location. He started the car from there, and after some time, what happened? 2 and 3 hours, he reached to the same location. That's called as a loop, doing the same thing. The problem in this thing is what happening. The problem in this thing, right, is a wastage of time, right? Wastage of resources. Resources will be what? Your petrol, your money, your car, right? and you are not getting the accurate result. So you want to go to the HSR layer, but unfortunately you have no idea of the Bangalore. You reach to the same location. You have started your journey from the same location at the same time, you reach to the same location. That's called as a loop. Now, this loop can be happen in the networking as well. This loop is also possible in the networking as well. And in networking, right, we have a two types of loop. One is called as a layer 2 loop, right? And another is called as a layer 3 loop. Layer 3 loop is a finity loop. It means that after the some amount of time, this loop will be end. Layer 2 loop is an infinity, right? So before we are going to understand the layer 2 loop, first we need to understand the layer 3 loop. So let's take example, right? We have a router over here. Okay, and then we have, let me do this thing in a GNS3 so that I can show you the practical as well. Loop is not good for anywhere, not even the real life, not even the networking. Because in the both the way, right, in a real life or in a networking as well as both the way you are wastage of resources of the network and the real life as well. So what I can do that, I don't have a lab, I think so. Let me check it. Do I have a lab for this one or not? It's been long. Yeah, I do have. So it was almost 8 months back. Yep. So you can see this topology right now. I have a default route, right? So I know this is the basic routing. So here I'm not going to explain you what is routing behavior right now. I'm just trying to explain you the layer 3 loop behavior. Okay, then we'll go to the layer 2 loop as well. So let me change the putty size I have, and let's see, do we have a configuration or not? Special default setting and save it. So you can see that on the router 1, I have a 2 links connected to the router number 2. On the top link, we can see that we have a subnet is 192.168.1.0/24. On the bottom side, we have a 192.168.2.0. Right, I hope the IP address is configured. Let me check. So let's go to router 1. So IP interface brief. Okay, I have IP address configured. You can see that 2.1 on the 1.1. So 2.1 on the 0/0 and 1.1 on the 0/1. Same thing on the router number 2 right now. So IP interface brief, right? Okay, I don't have. So let's configure it. Interface 0/1. I have a 192.1.2/24 and no shutdown. And interface 0/0 IP address will be 2.2. Guys, please pay attention, right? And this topic, the layer 3, it will clear the more concept of the routing. Okay, so now we have done with the routing IP addressing. Let's do one thing. Let me check my routing table. I do have a one default route. Guys, can be on mute. So I have a one default route pointing to the 1.2. So if you see on the router 1, I have one default route that is pointing to the router number 2 on the top link. And at the same time, on the router number 2, also I'm going to give the default route that is pointing to the 2.1. Forget this concept right now, what I'm giving, like what is the default route, these things, leave it right now. Understand the concept. So let's take example. What happened? Let's take example. What happened if I'm going to ping from the router number 1? If I'm going to say that, hey, I'm going to ping, right, from the router number 1, 8.8.8.8. If I'm going to ping the 8.8.8, source could be anything, right? Let's say example, the source will be 1.1. And destination is what? 8.8.8.8.8. That's the destination, source and destination. So when I ping 8.8.8, right? So when router 1 will receive this packet, what router 1 will do that? According to the router 1 routing table, right? He looked the routing table. He see that, hey, I don't have a 8.0.0 information, but I do have a default dot. And according to my routing table, I will forward the packet to whom? 1.2. Again, I'm repeating, when the router 1 will receive this packet, he look up the 8.8.8 in my routing table. I don't have a 8.8.8, but I do have a specific route. According to my routing table, I'm going to forward the packet to whom? Router 2. Why? Because my next stop is 1.2. When the router 2 will receive this packet, what router 2 will do that? It will look up the routing table and he said, hey, do I know about the 8.8.8? According to the routing table of R2, he said, hey, I have no idea of the 8.8.8.8. So same packet, when the R2 will receive it, it will look up the routing table and say that I know I do not have any idea of the 8.8, but I do have a default route, which is pointing to the 2.1. So now the router 2 will forward the packet to whom? Router 1. When router 1 will receive this packet, what router 1 will do that? Again, look up the routing table and forward the packet to whom? 1 or 2. When again router 2 will receive this packet, what router 2 will do that? Look up the routing table, forward the packet to whom? 2.1. So this will be going on continuously. But the benefit of the layer 3, right? This is the layer 3 loop. The benefit of the layer 3 loop is what? We have in the layer 3 header, or we can say that in the IP header, we have a field is known as a TTL, time to live. It's a 8-bit value, right? If you see the name, it's saying the time to live. It's a 8-bit value. 8-bit means what? 0 to 255. So what happened when the router has first started the sending the packet, right? When the router 1 is going to first send the packet, right? What happened in that time? They will put the TTL as 255. When the router 2 will receive this packet, they will decrement the 1 TTL. And now again, he will forward the packet to whom? This guy. How much? 254. When the router 1 will receive this packet, what he will do that? He will decrement the TTL 1 and he will forward the packet with the 253 now. When the router 2 will receive this packet, he will decrement the 1 TTL and he will forward the packet with the 252. And same process will be going on. Once the TTL will become 0, the packet will be dropped. Once the TTL will become 0, the packet will be dropped. So on a layer 3, right, guys, please pay attention. On a layer 3, we have a mechanism. We have a guy, right, this guy name is a TTL. He said that, hey, don't worry about that. I do have an ability to prevent the loop. I do have an ability to prevent the loop. Once the TTL will become the 0, right, once the TTL will become the 0, the packet will be dropped. So this is how on the layer 3 network, we are preventing the loop based on the TTL. Let me show you the practical. What I can do that, I'll just capture this particular thing, any of the thing. It's R10/1. Okay, let me. And element of the lecture. I'll say the ping e.8.8.8. Use packets, right? The loop is there. And now if you see TTL4 2, no response. And if you go to another one capture, if you see the TTL1 and then last TTL is TTL0. So on both the link, you can see that packet is going on, right? On both the side. On both the side, the packet is going on. Only the difference is what? Right? If you see in the downside, the top link 0/1, on the top link you can find, right? The TTL1 and then 0. And after that, what happened? If you see, right? Exceeded. Time to live is exceeded, right? If you go to IP header, right? The TTL is 255, but it's saying that time to live exceeded, right? Why? because now the packet is going to drop now. This is the last packet that we have over here. That's a TTL1 and that's a TTL0. So on a layer 3 header, right, on an IP header, we have a TTL field. On IP header, we have a TTL field. That's ICMP protocol, because ping is going to work on the ICMP protocol number 1, and we have a TTL over there. That's an 8-bit field. So on a layer 3 header, right, we have a TTL field that's helped to prevent the loop. That's why we call as a finite loop. Why I'm saying the finite loop? Because at the end of the day, right, once the TTL will become a 0, right, the loop will be end. So on a layer 3, on a layer 3, we have TTL, right, to prevent the loop. TTL is a 8-bit number, 0 to 255. Once the packet is to the TTL 0, then packet will be dropped. But how about the layer 2 now? If you see in the layer 2 packet, right, layer 2 header, do you see any TTL field over there? I don't have any TTL over there. I just have IPv4, that's a type. We have discussed this thing. I have a source MAC, distance MAC. I don't have any TTL mechanism on the layer 2. So if you don't have a TTL mechanism on the layer 2, who will prevent the loop now? Let's discuss this thing. Let's take example. What I can do that, I'll simply create the one topology. So I have a switch 1, right? I have a switch 2. Right? So I'm just gonna connect this link like this way, right? And I have a PC1, I have a PC2, right? And switch 1, switch 2, PC1, PC2, and the IP address we have over here. Let's take example. I have IP addresses. Let me decrease the size. I see the IP will be 101.1.1, MAC will be E. Same thing, IP will be 101.2, the MAC will be B. And now I'm going to provide the connectivity between the wire media, right? Because we are using the wire technology, not the wireless. And now this interface we can call as a 0/1, 0/0. This interface is also 0/0. And this interface we can call as a 0/1. This interface is 0/1 as well as. First, understand the concept right now. Forget the loop behavior. Understand the concept. When the PC1, right? When the PC1 is gonna send the packet, he said, hey, I like to ping the 101.1.2. What happened? The PC1 will look up the ARP table. Hey, do I have any entry for the 101.2? No, I don't have. So what he will do that? First, it will generate the ICMP request packet. The ICMP request packet eventually will be dropped. But first, it will go on the hold, right? And then it will be dropped. Then what happened? He will get the ARP request packet, right? In the ARP request packet, what happened? We have a source MAC will be A, destination MAC will be FFF. And then source MAC A, destination MAC 00, source IP will be 101, destination IP will be 102. Now, when the switch PC1 is going to send this packet to the switch 1, what is the behavior of the switch 1? The behavior of the switch 1 is going to learn the MAC address. What MAC address I'm going to learn? On a 0/0, I'm going to learn the MAC address is A, right? Now he will broadcast this packet on this particular interface. Once the switch 2 will receive it, switch 2 will do that? He will receive this packet and he will learn the MAC address A over there. Always learn the source MAC address. And now he will broadcast this packet on which interface? This particular interface. And the PC2 will receive it, right? Do you see any loop is there right now? Do you see any loop is there right now, guys?
No, there is no loop.
There is no loop. There is no loop, right? Because we just have a, guys, it's very important. Because we just have a single link. That's why we don't have a loop. We just have a single link. That's why we don't have a loop in your network. If you see my layer 3 topology, I just manually created the loop over there, right? I added the 2 links over there. If you have a single link, on a single link, there will be no loop. If you're going to add the redundancy or multiple link, then you will have a loop in the picture. So right now in my topology, if you see,
If there is a bundle, if there is a bundle of links,
forget the bundle right. Forget the bundle right now, right? Leave that. So if you see right now, I have a single link. What happens if this link goes down? Try to understand if this link goes down. This mechanism is called as a single link failure. This mechanism is called as a single link failure. Why I'm called as a single link failure? If your link goes down, there will be no communication between this PC to this PC. Right? If you have a single link, there will be no loop. But the problem with the single link is what? You have a one link only. If the link goes down, you don't have any communication. So to avoid this problem, what I can do that? To avoid this problem, to avoid the single link failure, right? To avoid single link failure, we can add multiple link, right? In a single link, there will be no loop. So to avoid the single link failure, what I can do that, I'm going to add the multiple link. So I'm just going to add the extra link over there, right? Link number 2 now, 0/2. 0/2 and 0/2. Now again, let me remove the MAC address from here, and let me remove the MAC address from here. And let me add this box and just look for this part. Now, again, what happened? The PC1, right? It will generate the ICMP request packet. ICMP request packet will be go on the hold. Eventually, it will be dropped because there is a only 2-second timeout there on the Cisco route, right? Then what happened? He will generate the ARP request packet. In the ARP request packet, we have a source MAC will be a distance MAC will be FF. This is my Ethernet header and this is my ARP header, right? When the PC1 will generate the packet, switch 1 will receive on this particular interface 0/0. What they will do that now? Again, source learn the source MAC address. So he will learn the MAC address 0/0 MAC address A over there. Now what he will do that? Based on the destination MAC information, he will do the broadcasting. He will forward the packet, right? He will forward the frame on this particular interface and this particular interface as well. Now focus. Understand, switch 2 has received this first packet, right? I'm just putting the number over there to understand your concept right now. So I'm just putting the packet number 1. So when the switch 2 will receive this packet, what he will do that? He will learn the MAC address 0/1 as a MAC A because switch always learn the source MAC address. Switch always learn the source MAC address if they don't have a MAC entry in the MAC table, right? And then it perform destination lookup. Right? Then it perform the destination lookup. So when the switch 2 will learn this MAC and for 0/1A, then what he will do that after receiving this packet, switch to look up the see the FFF. I need to broadcast this packet. He will forward this packet to the PC number 2. At the same time, he will forward the packet to whom on 0/2 interface. Okay. Now, same way, this switch 2 will receive the second number of packet on this particular interface 0/2. What he will do that? He will learn the MAC address 0/2 and A. And what he will do that? He will just forward the packet to this guy and this interface as well. This is my 3rd packet and this was my 4th packet. Okay. Now, when the switch 1 will receive this 3rd packet on which interface 0/2, he will learn the MAC entry 0/2 will be A MAC. And what he will do that again, he will circulate this packet to the switch 2 and he will flood this packet to the PC1 again. So PC1 has generated the packet, again he is receiving it. Now what? Same way, this guy will forward the packet to the switch 1. On this particular interface, I will learn the MAC A, right? 0/1, this one, right? And what he will do that? Again, he will forward the packet to this guy. And again, this packet will be down to the switch 2. Again, he will receive it. And again, the MAC will be flapping. So can you see that the same loop will be going on in the circular way? At the same time, your MAC will be keep flapping. The reason is that MAC flapping, right? On every time, switch will receive the packet on the different interfaces with the same MAC addresses. Is it possible? Remember the day 2 or not day 2, the switch date 1 classes or day 2 classes. You cannot learn the same MAC address, right? You cannot learn the same MAC address in the one MAC table because each VLAN has a different MAC address table, right? You cannot learn the same MAC address in the one VLAN. So right now the loop is there over there. Right now the loop is there, right? And this loop is an infinite loop. Why I'm saying the infinite loop? Because there is no TTL. Because there is no TTL. And because of this reason, can you imagine that what happened? It's totally wastage of bandwidth of this particular link, the wastage of bandwidth of this particular link, the wastage of bandwidth of this particular link, and the wastage of bandwidth of this particular link. At the same time, the CPU will be high on the switch 1 and the CPU will be high on the switch 2. Now, let's assume that if you have 100 plus switches in your network, if you have 100 plus switches in your network, can you imagine that if the switch 2 has a connectivity with the switch 3, switch 4, switch 5, switch 6, 6, 7, whatever the users are present in that broadcast domain will receive this broadcast packet. Whatever the users, if you have 100 plus switches, and in the 100 plus switches, if you have a 50K users, right, all the 50K users will receive the broadcast stream, and there's no mechanism to prevent the loop. Let me give you the example on the Cisco packet tracer, then you will understand pretty quickly.
This is a layer 2 switch, right?
Yeah, this is the layer 2 switch. Not even the layer 3 switch also will be there, because on the layer 3 switch, if you remember yesterday I talked about, right, by default all the interface are the layer 2. Okay, so here we go, switch, and I'll take the switch 1, I'll take the switch 2, and I have some PC. And always remember, right, only for the broadcast traffic you will have a loop, not for the unicast one, right? Because if I'm on the unicast packet, right, he will just forward the packet to the correct on the interface because of the MAC table. Yeah, if you have a multiple MAC entry, right, like a duplicate MAC address, then you have a loop in the picture. I'm going to add another interface over here. And let me do this thing. Let's give the IP address on this interface. Desktop will be 101.101 and 101.2. All right. Now I'm going to do some configuration. Leave this part right now. What I'm doing right now, just ignore it. And I will do this as well. In a single link concept, you don't have a loop. But the problem with the single link is what? You don't have a backup. So if the single link goes down, you don't have connectivity between the PC1 to PC2. So now let's create a packet. A broadcast packet. Yeah, go on.
So actually, I have been to this kind of scenario before. So just want to get a little bit clarification. We had an issue in port flapping in one of our job, right? So I thought maybe port flapping is
always
like
create the MAC address table flapping. The port flapping always create the MAC address table flapping, right? Your MAC address table always keep flapping because they will learn the MAC address, they will drop the MAC address, they will learn the MAC address, they will remove the MAC address, they will learn the MAC address, and they will remove the MAC address. That's called a MAC flapping as well.
Right. So in order to fix that issue for port flapping,
You need to correct the ports. There is no issue with the protocol side. You need to correct the ports.
But spanning tree does help that.
That's I'm coming to the point. So a spanning tree doesn't see if you are changing somewhere in your network, then a spanning tree comes in the way. Then this question will be clear by the end of the spanning tree because we two different things we have over here.
Okay, that's fine. So basically, loop is different, port flapping is different, right?
Flapping is totally different. Flap, see, this link could be also flap, right? The access port.
Right.
This link, but this is a single link. So do you think there will be loop over there? No, right? On the single link, we don't have a loop.
No, it can't be loop here, right? On a single
Of
link.
course, but if the flapping over here, right, there will be a loop.
Flapping, sorry for flapping is just up and down port, right?
Yeah, that's
Getting
up and down.
up and down.
So if the
Yes,
flapping is
but
occurring
loop is
over there,
something different.
but flapping create a issue, right? Or the MAC address. Let me complete this one, then I'll explain you those things. Don't worry about that. Let me finish.
No problem. That's fine. Thanks.
So let me ping from here to here and have a look. So the ICMP packet they will create it, right? So this packet will go on the hold. And now after that we have a ARP. And in this ARP we have a broadcast packet, FFM. Now what PC1 will do that? Maybe forward the packet to the switch 1. Now what switch will do? It will send the 2 packets to the switch 2. Can you see that? 2 packets. Now what switch 2 will do that? He will send the 1 packet to the PC2, 1 packet to the PC1. Only 1 packet. And then again, switch 1 will be send this packet to the switch 2. And now let's put the auto capture play. And let's see the magic of the layer 2. Let's keep loading. There's no mechanism. I'm not doing anything. It's auto capture play. And you can see that. That's why I call the layer 2 loop is the infinity loop. There's no mechanism. Only one mechanism you have what? You need to shut down this interface manually. You need to shut down this interface manually. So the layer 2 loop, if I talk about, right, what issue is creating the layer 2 loop? The first issue, the layer 2 loop will be created. Wastage of bandwidth. Second is what? Wastage of CPU of the switch. It creates the congestion in your network. Of course, the complete bandwidth will be utilized by the only R packet, right? And then MAC address table will be flapping. And eventually, right, once after then 2, 3, 4 hours, right, even if you make a keep, like even if you do this thing on the packet tracer, and if you leave this like a packet tracer for the 1 hour, right, and if the loop is there on the packet tracer, your personal laptop CPU will be high. So eventually there will be a chance, right, your device will be crash. Your device will be crashed. So that's a problem with the layer 2 loop. And it's an infinity loop because there is no mechanism. We don't have a TTL on the layer 2. Like we have a TTL, right, in the layer 3, but we don't have a TTL in layer 2. Right, that's the biggest issue of the layer 2 loop. What will be the solution now? The solution, if I talk about, right, the solution, if I talk about, what you can do that, right? You can put the one network engineer, right? You can put the one network engineer over here on the switch 1 side, and you can put the one network engineer on the switch 2 side. So when they will feel there is a loop, what he will do that, he will just shut down the one interface. Any of the interface, that's fine. I need a redundancy, right? I need a multiple links. I cannot go with a single link because if there will be a single link, then issue comes in the picture, single link failure. I need a multiple link. I need a redundancy. If there is a redundancy and if somehow the PC generate the broadcast traffic, right? If the PC will generate the broadcast traffic, the infinity loop comes in the picture. So I need someone who can keep monitor this link. And if they find, hey, there is a loop is going on, they will shut down the link manually. And in that way, we can prevent the loop. But do you think, I'm always saying that manual is always good sometimes, right? But in this case, the manual is a bad solution because we cannot put the network engineer 24/7 on the network side, right? And they cannot keep monitoring. They cannot put like an eagle eye, right? You need to put the eagle eye on the link side. Oh, there is a loop. Let me shut down this link. So to avoid this problem, right? To avoid this problem, there's a girl, right, who comes in the picture and said that, hey, let me do one thing for you guys. And he introduced the protocol is known as a spanning tree. So this was the girl, right? She was an engineer, right? Computer programmer. She introduced the protocol is known as a spanning tree protocol. And she said that, okay, let me introduce this guy, right? And what this protocol is going to do that, the major goal of this protocol is just going to block one of the interface. One of the interface means what? For example, we have a switch 1 and we have a switch 2, right? What he will do that 0/0, 0/0, and 0/1 and 0/1. So what this protocol is going to do that, he keeps sitting on the switch side, right? By default, this protocol is enabled. First of all, understand this concept. By default, this protocol is enabled. So this protocol is by default sitting on the switch 1 and the switch 2 as well as. If this guy find, hey, there is a multiple links, what he will do that, he will shut down the one link. Any one of the link, he will shut down one of the link and there will be no loop. So of course, my all traffic will go by the 0/1. My all packet will be exchanged by the 0/1. If somehow 0/1 will be down, then what happened? Automatically spanning tree protocol, this guy will up this interface. So my all traffic will now go by the 0/0. Once this backup, once this link will be the link issue will be solved. Once the network engineer will solve this link issue, then what happened? Automatically, this link will be goes down, and my all traffic will go by this one. And you're not gonna do anything for this thing. All this thing is done by the spanning tree protocol. So thanks to her. So she resolved this issue right in the 90s, 80s time. So again, if you look for the Cisco, right? Cisco came in the picture is near around 1984. If you go with the Cisco Wikipedia, and you will see that's a 1984, the Cisco came in the picture, right? But before the Cisco, right, the spanning tree protocol, right, was introduced. So I think so 1980, yeah, it's a 1984. So before that one, the spanning tree protocol comes in the picture. So we have a protocol that's known as spanning tree. What a spanning tree protocol is going to do that, right, for you guys. So by default, spanning tree protocol is enabled, right? So he will block the one of the interface. Any of the interface, that's not a big deal, but he will block one of the interface. So if there is a blocking one of the interface, try to understand, will there have any loop? No. All my traffic will receive on 0/0, and he'll forward to 0/2, and he'll forward the 0/0. That's all. So if somehow, if the 0/2 goes down, right? If somehow 0/2 goes down, then this will be up automatically. So everything will be done by this amazing person. So by default, right? By default, spanning tree protocol is enabled. By default, spanning tree protocol is enabled on layer 2 interface. Layer 2 interface means what? Access port and trunk port. So on both the interface, right, your spanning tree protocol is there. So on this particular interface, spanning tree is there. At the same time, this particular interface, spanning tree is there. So if you see the loop over here right now, The reason is that I have disabled manually I have disabled that spanning tree. Yeah, you do have ability, you can disable it, but don't do that in the production environment. Don't even try it. Okay, so if you're not like if for learning perspective, you can do on the Cisco packet tracer, but don't do that on the real network. So spanning tree protocol, the major goal, right? The major goal of the spanning tree protocol is what? The major goal, spanning tree protocol, to prevent loop, to just by blocking one of the switch interface.
Sir, if there is a
Have
more than two links between the switches, how you gonna?
Sorry,
So
sorry.
how will you do that then in that case?
I didn't understand your question.
I mean, on let's say on this particular example, there are two links in the switch one and between switch one and switch two, right?
Mhm.
So imagine if there are like more than two links, five links, for example.
That's I'm coming to the point. Hold on. I'm coming to the
The
point. So that's how the major goal of the protocol is what? It's gonna block the one of the interface. So spanning tree protocol, right, has a multiple types. If I talk about the types of the spanning tree protocol, they have multiple types. Spanning tree protocol has a multiple types. It's a layer 2 protocol, guys. Okay, so the first type we have is called the CST, common spanning tree protocol, right? Second tab is known as the PVST for VLAN, spanning tree protocol, right? The third type we have is known as a, I'm talking about the Cisco perspective, okay? Rapid PVST. Just copy the name from here. And the fourth type is known as a MST. Multiple spanning tree protocol. So four types of spanning tree protocol we have, right? CST, common spanning tree, PVST, per VLAN spanning tree, RPVST, rapid spanning tree, MST, multiple spanning tree protocol. Now, which one we have to learn? And which one is gonna use in the production network? So the thing is that, right? Mostly in the production network, if I talk about, these two are using RPVST, right? And MSTP. Mostly in the production network. Somewhere you can find it PVST. But you cannot find the CST. It's totally obsolete. CST is a totally obsolete one. But the problem is that there is a hierarchy. Hierarchy in the sense of what? If you want to understand the MST protocol, then you need to understand the RSTP protocol or RPVST protocol. RSTP is IEEE standard, RPVST is a Cisco providing. If you understand the RPVST protocol, then you need to understand the PVST protocol. And if you want to understand the PVST protocol, then you need to understand the CST protocol. So there's a hierarchy we have. So we cannot jump directly to the PVST or directly to the RSTP. You need to understand the CST first of all. So the focus on the name first of all, because if your name is clear, right, you can easily understand the each spanning tree. So common, that's the first word. Second word, per VLAN. Third word, rapid. Fourth word, multiple. The common means what? The common means he's saying that, right? For all VLAN, we have a single spanning tree instance. Here, the meaning of instance you can understand in this way. It's talking about the algorithm. Okay. Now, it means that let me make it easy. For all VLAN, matlab from 1 to 4094. So sorry, from 1 to 4094, right? You have this range of VLAN, right? For all the VLAN, you have just a single guy, a single spanning tree. Single guy represent all the VLAN. Single instance. Per VLAN, the per VLAN itself is saying that is what? For every VLAN, for every single VLAN, you have a specific spanning tree instance. Again, instance means what? Algorithm. It means that for VLAN number 10, you have a 1 instance. For VLAN number 20, you have another instance. So take example. If you have a 10 VLAN, then how many instances you have? If you have a 10 VLAN, or let me get 100 VLAN. If you have 100 VLANs, right, then you will have a 100 instance, 100 spanning tree will be there. There will be 100 like this guy. There will be 100 like this guy. But the problem of this guy is what? It's slow. I'll take a different color for the problem. So the problem is a slow. This is also slow, right? Same issue, right? If you see the name, it's still the per, right? Only the difference is that it's a rapid. The meaning of rapid means what? Fast. The meaning of rapid means what? Fast. So the rapid means what? Same purpose, same behavior. Only the thing is that it's a fast one. Now, but the same thing for VLAN number 10, 1 instance, for the VLAN number 21 instance, right? Now, if you see common PVST and rapid PVST, each one has some issue. If I talk about the issue of the CST protocol, right? If I talk about the issues of CST protocol is what? You cannot achieve the layer to load balancing. You cannot achieve it. You can do the layer to load balancing in the PVST. You can achieve the layer to load balancing. Load balancing is what? I can send the traffic on both the link. Normally, understand this concept, guys. Switch 1, switch 2. We have a 2 link, right? So normally what happens if I'm going to use the CST protocol? In a CST protocol, what happened? One of the link will be blocked, 0/0, 0/0, 0/1, and 0/1. Any one of the link will be, maybe this link is blocked. So I can only send the traffic from the one link. But in PVST, what happened, right? I do have an ability, I can utilize both the link. Even in the RSTP, RPBST, I can utilize both the link. I can send the traffic from both the link. So there will be no wastage of hardware. There will be no wastage of the bandwidth. But the CST problem is what? The CST problem is the load balancing. Beauty part, if you see, right? The pros, if you see, the pros of this guy is what? A very low amount of CPU required. Let me decrease the size. I don't have a space. I want to mix everything in a single page right now. Pros is what? Low amount of CPU required. Of course, right? If you see, I just have a one spanning tree instance in the CST protocol. Just one. So if you have a one person, it's very easy to manage the one person. The switch can easily manage the one algorithm, right? Instead of managing the 100+ algorithm, it required this guy. If I talk about the PVST bronze is what? It requires the high amount of CPU. Pros, if I talk about, we have a load balancing. Same thing, pros and cons are another cons of the PVST. If I talk about, it's slow. If I talk about the rapid PVST, we have a, we don't say the cons this guy, again, high amount of CPU, load balancing, and the fast. If you see things right properly in the three protocols, CST, PVST, and RPVST, everyone has some issues, man. What is the issue of this guy? What is the issue of this guy? Sorry, not this one. What is the issue of the RPVST? Everyone has some issues, right? To avoid all this problem, then we came with the concept is known as the MSTP protocol. MSTP doesn't have an issue. You can, it's a combination, you can say that it's a combination of all spanning tree. So you have a, you can, if you want to implement the MSTP protocol, then you can use the behavior of the CST. For example, if you don't have a much amount of CPU, you can go with the MSTP. If you want to achieve the layer to load balancing, you can go with the MSTP. If you want to make a faster, you can go with the MSTP. Everything is possible in the MSTP protocol. So these things, right, is a very important according to the interview perspective or the design perspective. So based on that, you can select which protocol is good for my network. For example, your switches does not have a high amount of C, because you cannot run the CST. First of all, I'll let you know, you cannot run the CST nowadays. It's not possible. Either you can go with the PVST, RPVST, or MSTP. You cannot go with the CST. So if you have a low amount of CPU, take example, very low amount of CPU, you don't have much amount of CPU, you can go with the MSTP protocol. Because in the MSTP, what happened? You do have ability, you can achieve the CST behavior. But if you really want a full control and you don't have an issue with the CPU, you can go with the RPVST. Because RPVST is a faster. PVST, normally people are not running the PVST protocol because it's a slow one. A very slow protocol. You will see that, don't worry. Guys, questions? Anyone has this question in this one? Or all good?
Okay.
All good? Now.
Yeah, I have a question.
Yeah.
So RPPST is faster than MSTP, right?
Both are same. I just made
Both
both
are same.
Right.
Okay, so
it's faster than the PVST.
oh no, that's fine. But I'm talking about, so in generally in different environments, most of the organizations they do MSTP or RPVST, or depends on the
Yeah,
situation.
PVST is not the recommendation to run it.
No, I'm talking about RPVST, not the PVSTP.
Okay, which one is recommendation?
In general, I mean situation like in general organizations most of the time. So the organizations are using MSTP or RPVST.
You're asking to me, which one is the recommendation to run?
Yes.
Yeah.
Okay.
So again, I mentioned that it's depend on the requirement. If you have a high amount of CPU, you can go with RPVST. If you have a low budget of CPU, you can go with the MSTP protocol.
But the speed is same.
But the speed same. But if you ask me which one, so for example,
Yeah, that's fine. I understand now. Understand that
for
question.
example, if you have a very less number of VLAN, like you have 5 to 6 VLAN, you can go with RPVST is fine. But if you have a very high amount of VLAN, maybe 100+ of VLAN, you have a 200+ of VLAN, in that case, you need to go with the MSTP.
Right. It depends on the number.
For the big network, it's going to run for the MSTP. For the small network, you can go with the RPVST. Now, understand the concept. What I told you that the major goal the major goal of the any spanning tree protocol, any protocol if you see is to what? It's a block the port. Block the port. Now, which port I'm gonna block it? That's a major question coming in the which port I'm gonna block it. So I will take the universal example, universal topology that everyone is using. So switch one, take example we have. Switch two, I have a switch three as well. Right? First tell me, do we have a loop in this picture right now in this topology? And
No.
great. Now, do we have a loop now?
It will have, yes.
Yes, it's have, right? So now let's put the interface number. So I can call it 0/0. I can call it 0/1. I'll call it 0/0. I'll call it 0/1 now. And 0/1 and 0/0. So normally by default, as I mentioned, that the spanning tree protocol is enabled. Now, don't ask me which protocol is by default enabled, RPVST, NPVST, we'll talk about later. But by default, it's enabled on all the layer 2 interface, on all switch port interface. Switch port means what? It's a layer 2 interface. Now, simple example that I'm giving right now. So normally when you go to the college, right? When you go to the first year of the college or second year of the college, in every classroom, in every classroom, what happened? There is an election is going on, and that election is called as a CR election. Either you can call it a CR, class representative, or if you are in the very like a my hometown, like a very village area, we are called as a monitor. So in a city side, the people are called as a class representative, and in like a village side, we call as a monitor. So in every classroom, we have a monitor and the class representative. What this guy is gonna do that? This guy is just gonna manage the classroom. This guy is gonna manage the classroom. Same thing. Every country has a president and prime minister. For example, in India, the prime minister is gonna manage the complete country, right? Same way in the different country, maybe the president is gonna manage the entire country. In a state, the chief minister is gonna manage the entire state. Normally in the district side, what happened? The district magistrate, right? A DM is gonna manage the complete district. Same thing in your family, your father is gonna manage the complete, your father or maybe mother is gonna manage the complete family. Same way in a layer 2 network, right? What happened? When you're just gonna put the interface over there, right? What happened? There will be an election, and in that election is known as a root bridge election. So when you're gonna connect the switch interface, right? When you're gonna connect the switch interface, there will be an election of what? There will be an election of root bridge. Why I'm using the bridge terminology? As I mentioned that, right? If you guys remember that in the starting of the day 1 class, first hub comes in the picture, after the bridge comes in the picture, and then switch, and then router and those things, right? Firewall and those things comes in the picture. Bridge, right? In a 1984, the Cisco came in the picture, right? Before the Cisco, there was a spanning tree protocol was introduced. And on that time, we were using the bridge technology, a bridge device, not the switch. So most of the terminology you will see in the spanning tree protocol from the bridge, right? And why I'm called as a root. Root means what? A center person. Root means what? A center switch. In a simple language, root bridge you can call it a center switch. Now, how you're gonna make an election of the class representative and monitor? How you're gonna make an election of the prime minister, right? How you're gonna make an election of the district magistrate? The person who has a good knowledge, right, will become the DM, right? Or we can call as a prime minister, right? They have a capability to run the entire country, entire city, entire state. Those can become the CM, prime minister, or DM, right? Same thing, right? In the switch, what happened? Everyone is trying to say that, hey, I will be the root bridge, or he will say that I will be the root bridge. Again, he will also say that I will be the root bridge and I will be the root bridge. Everyone is trying to say that I will be the root bridge. So everyone is trying to claim, hey, I'm the root bridge, I'm the root bridge, and I'm the root bridge. It's not possible that everyone can become the root bridge, right? It's not possible that in a single team, everyone can become the manager. There will be one manager or multiple engineers over there. All the engineers is gonna report to the manager, a single manager, right? So in the switch side, the knowledge, right? The knowledge is known as a bridge ID. The knowledge is known as a bridge ID. Every switch has a bridge ID. The size of bridge ID is what? It's a 8 byte. The size of bridge ID is what? It's a 8 byte. It's a combination of two things. The bridge ID is a combination of two things. One is called as a MAC address, which is 6 byte, right? Another is called as a bridge priority. Again, I'm repeating, we are using the terminology from the bridge. Bridge means what? You can understand as a switch. So the bridge priority. So total size is a 8 byte. So of course, the MAC address is reserved for the 6 byte. So 2 byte is for the priority. The default priority is a 32678. Why is 32678? We'll talk about later. Leave it right now. Okay. But understand the concept, the basic overview. The default priority is a 32768. The lower bridge ID will be more preferable. It means that lower bridge ID will be the winner. To exchange the bridge ID information, we need some other person, and that person is known as a BPD, Bridge Protocol Data Unit. BPDU is nothing but it's just a guy who will carry the bridge ID information. So for example, let me explain you this part. Let me put over there right now. So the bridge ID of this guy is what? The bridge ID of this guy will be, I'm just considering the MAC address is A32768. That's a default priority. Its total is a 8 byte, right? The total is a 8 byte. So this information we have, same thing. This information will be on the switch 2 right now. Come on. This guy will be B now. And this guy will be C, right? So let me put it with a different color. Right? By default, spine protocol is enabled on all the switch port interface. At the time of election, what happened? We need to exchange the bridge ID. Why we are going to do the election? To introduce the center switch. Why we are going to introduce the center switch or root bridge? So that they can manage my layer 2 domain. To manage the classroom, we have a class representative or monitor, right? How the election comes in the picture? Based on the knowledge. The knowledge is known as a bridge ID in the switch side. A bridge switch has a bridge ID. That's the size is the 8 byte. It's a combination of the MAC address plus bridge priority. The default priority is a 32768. Lower bridge ID will be the winner. To exchange the bridge ID information, we have a guy that name is a bridge protocol data unit. Bridge protocol data unit is nothing but it's just like a packet. The packet that we have seen, that ICMP request packet, this is the packet, right? This is the ICMP request packet, right? If you see, not this one, let me give you this one. Can you see that this is the ICMP protocol? So we have a ICMP packet, Internet Control Message Protocol. This is the packet. Same like that, we have a bridge protocol data unit. What I told you that initially everyone is gonna say that, hey, I will be the root bridge. He is gonna claim that I'm in the root bridge. He will be claim that I'm the root bridge, right? He will also claim that, hey, I'm the root bridge. How they will claim that I will be the root bridge? By exchanging the bridge ID information. How they will exchange the bridge ID information? We need some person who will carry this bridge ID information to the switch 2. Switch 2 will send this bridge ID information to the switch 1, right? Switch 3 will send this bridge ID information to the switch 1 and the switch 2. Who will is going to carry? Normally, when you travel somewhere, your bus, your train, your aeroplane, right? These things are carried to you, right? If you want to send us some luggage, the courier guy will carry your luggage. Your IP protocol, your Ethernet header that we have seen that, it's carry the frame. IP is going to carry your data, right? Same thing, to carry this bridge ID, we have a person name is called as a BPDU. BPDU is nothing but it's just a one packet. BPDU is a packet. Bridge protocol data unit. It's a layer 2 packet that carry the bridge information. Again, bridge means what? I'm talking about the switch information. Whatever the information, they will carry that. They will carry the information like bridge ID, right? Host, interface, not interface, root bridge information, or many more things, etc. Right now, you don't need to focus those things. Only focus on this part right now, bridge ID. So when the switch 1 is ready to start, what happened? He will send the BPDU packet. And in this BPDU packet, what information they will say that A plus 32768. That's my information. Same thing. He will say the BPDU packet to whom? Switch 3, A plus 32768. Switch 3 also gonna say the own BPDU packet, and he will say that, hey, I have a information C plus 32768, because he is also claiming that I'm also root bridge, right? Normally, in a classroom, everyone is trying to say that, hey, I will be the monitor of this classroom. I will be the representative of the classroom. Same thing is happening over here as well. B plus C plus. Can you see that? Everyone is trying to exchange the bridge ID information. So eventually what happened? Eventually, the switch 1 will have all the bridge ID information. He will have my own one. He will have this one. And he will have this one. Right? Switch 3 also will have all one. And switch 2 also will have all one. Eventually, if you see that, switch 1 is going to share the own information to the switch 2, he will maintain it. Switch 3 is going to share this information to the switch 2, he will maintain it. And he will have own local one as well. Now what? Every switch is going to try to look up who has a lower bridge ID. Every switch is going to try to look up who has a lower bridge ID, because the lower will be the winner. The lower will be the winner one. After looking for each and everything, the first it will look up which field. The first it will look up the priority. The first election, it will look on the priority. Look for the lower priority. Everyone has the same priority. 32768. Okay, that's tied. Let's go for the lower MAC address now. Now, this time, the MAC address that I'm going to look for, that's called as a base MAC address. Why I'm calling this base MAC address? So in election, or we can call it the bridge ID election, sorry, in the bridge ID, we are looking for the base MAC address. Let me tell you what is base MAC address. Guys, give me a minute. Alexa, stop. So lower base MAC address. Now, take example. We have a switch 1, right? And we have a switch 2. And we have a switch 3 as well. Right? This is the port we have. This is the port we have. This is the port we have over there. So this port also has a MAC address. This port also has a MAC address. This port also has a MAC address. Right? This is the switch 1, the name the switch 1 that I have defined. Right? That I have defined. I can remove it. Because we are a human being. For my understanding, I have defined it. But normally, does switch has any name over there? No. Normally, when you take a brand new switch, what you got? Okay, I took the switch 2960. That's your telling. You are not saying that, okay, this is the switch 1 or switch 2. When you're purchasing the switch, you're saying that I took the new brand switch. How does the switch is going to identify this is my identification and this is my identifier, this is my identifier? So normally, apart from the interface, right, each switch has a base MAC address. That's base MAC address I can call as A, B, and C. Interface MAC address is a different thing. Base MAC address is a different thing. Let me show you this thing as well. Come on. That's for the complete switch, not for the interface. Again, I'm repeating, that's for the complete switch, not for the interface. If you look for the interface, right, I'll show you that as well. Let me take a sneak for this one. Right, and if you look for the any interface one, so interface 0/1, right? You can see that this is the interface MAC address. It's different. Can you see that? It's different. Interface MAC address and base MAC address are totally different thing. So when I comes to the bridge ID, right? In the bridge ID, we are going to look for the lower base MAC address. Understood? Now, after deciding, after extending the all the bridge ID information to all the switches, right? All the switches has all the bridge ID information. Now, switch 1 say that, hey, looks like my MAC address is lower one. Because the priority get die, I'll look for the lower MAC address. My MAC address is A. A means what? 10. B means what? 11. Hexadecimal. C means what? 12. So which one is the lower? After exchanging the BPDU packet at the initial stage, right, we have decided the switch 1 has a lower MAC address. Switch 1 has a lower MAC address. So what all the switches is going to do that now? Now all the switches is going to tell that, hey, listen, you have a lower MAC address. You have a lower MAC address. So you will be the root bridge. So after the extending all the bridge ID information, now the switch 2 and switch 3 also will confirm that the switch 1 has a lower MAC address. Now he will be the root bridge. So once the switch 1 will become the root bridge, all the other switches will become the non-root bridge. Because you will only have a single root bridge. Right now, in a common spanning tree protocol I'm talking about. In a PVST, as I mentioned that for each VLAN, you have a separate algorithm. Okay, so you will have a multiple root bridge in the PBST, RSTP, and MSTP. But I'm talking the CST protocol because I mentioned that you need to understand the hierarchy way, right? So understood this concept. I have a one root bridge, another will be a non-root bridge. We are talking about the CST perspective. Now what? Once we have done with the election of the root bridge, next election comes in the picture is what? Next election comes in the picture of now. After, let me go with a little bit smaller. After electing the root bridge, now it's time to elect the role of interface. So if I talk about the role of the interface, whatever the role we have interface, we have a designated port. Simply we call it a TP port. Next type of port we have is called a root port. We call as a RP port. Another type of port as called as a blocking port. Alternate blocking. Something AL short name is ALBK, something is coming. I'm not pretty sure what's the short name of this guy. I'll just put the BP port. BP. So we have a ports over there. Question for later. Do all kinds, if the switch ports have their own MAC address or only certain switches? Every switches, not every switches are video. Even if you go with the router interfaces, even all the router interfaces have a separate MAC addresses. Now, we need to elect the port. Before I'm gonna make an election of the port, I'm gonna show you something very important. Let me show you in the book. Okay, hold on, let me pause the record. Entry. So we'll talk about the BPO later on. This what are the types of the configuration to be later on. Don't worry about that. Okay, so this is the multicast address for the BPO 0180C20000. That's a multicast reserve MAC address for the BPO. Source MAC address will be the interface MAC address. Destination MAC address will be the 0180C2000. That's a field that we have in the BPO that we'll discuss in the Wireshark. Don't worry about that. The point that I want to show you, this is the bridge ID, right? It's an 8-byte number. Bridge priority is a 2-byte. The default is a 32768. You can go with the 16-bit. 16-bit means what? 65535. The MAC address is a 6-byte, right? It should be the base MAC address. So not this one, yeah. The cost. That's I need to guess me. And this one as well. And this thing as well. I just need to write down this thing. That's it. Because the cost is very important role over here. Now, before we are going to discuss this part, because we have done with the root bridge election, right? Lower bridge ID will be go with the root bridge, and not all the switches will become the non-root bridge. Now, before going to election of the root port and interface ports, right? Every interface, right? Every interface has some cost value, and this is very important. Because based on the cost, right, port will be elected. Again, lower cost always prefer. Anyway, even if you do the routing as well. Another thing is that two types of cost you have, right? Again, these things not comes in the interview so much, right? I'm just giving you for your knowledge perspective, nothing else, right? Cost you have. One is called as a route path cost. As name suggesting that, who is the root bridge right now? Switch one, right? So total cost from the non-root bridge to the root bridge, that's called as a root path cost. Total cost to reach the root bridge from non-root bridge, known as a root path cost, right? Another type of cost we have called the path cost. Path cost is simple. Interface cost is known as a path cost. This interface cost is known as a path cost. Take example of, let me explain you this part. So we have a switch one, right? We have a switch two. Again, guys, we will do the lab of each and everything. Don't worry about that. Okay. Switch three right now. I'm just giving you right now the basic overview of the spanning tree protocol. We have a deep dive of each topic. So we have understood this link right now. So take example, what is this? What I can consider. If you see each link speed have a different cost over there. If you go the link bandwidth right now, don't look for the older one, look for the newer one. Right? So if you go with the 4 Mbps, you have a cost 250. If you go with a 10 gig, you have a cost is 2. So lower bandwidth has a higher cost. If you look that, lower bandwidth has a higher cost. See, 4 Mbps higher, lower bandwidth is there, higher cost. Lower bandwidth, higher cost. Higher bandwidth, lower cost. Let's take example. The link that I have in switch 1, switch 2, switch 3 is this one. I'm just considering it 1 gig. 1 gig means what? The cost will be 4 over there. The cost will be 4, right? So I'm just considering the 1 gig link, and the cost will be of this guys of 4, 4, 4, and 4. Assume that this is the root bridge, this is the non-root bridge, and this is the non-root bridge. So I'm explaining you the meaning of root path cost and the path cost. If you understand this concept, it's very easy to understand the port rule then. Okay. If you are sitting on the switchboard, from the switchboard, if you want to go to the root bridge, what will be the cost? 4 plus 4 plus 4. It's 12, right? So 12 will be root path cost. From the switch 4 perspective. If you go from the switch 2 to the root bridge, 4 plus 4, 8, right? So from the switch 3 perspective, sorry, the cost will be RPC, the cost will be 8. But how about the path cost? This is called as a path cost. This is called as a path cost. This is called as a path cost. Again, this is the default value. These costs are a default value. You do have an ability to change this cost. I'm again repeating, you do have ability to change this cost. These are the default value cost we have. So I hope you understand the meaning of root path cost and path. If you guys have any question in this one, you can ask me. Or it's clear, just let me know so that I can move to the code volume.
Hello, sir.
Yeah.
Why we
Yeah,
change
sir.
the value, sir?
That's we'll discuss later to manipulate the path. To
Okay,
manipulate
okay.
the logic.
Okay, sir.
So, what is the general definition of cost? I mean, if we overall,
The
because
general definition of the cost is gonna determine the better path to reach the root bridge.
so in spanning tree, we always do calculate the cost, isn't it?
Not only the cost, many things we are looking. One of the thing is the cost. Gradually, many things will comes in the picture. So one of the important factor of the cost.
So it is the spanning tree, the cost has a major, obviously major factor on it to
Yeah,
calculate the root bridge.
not root bridge, to calculate the port roles.
Sorry, the line is breaking up to calculate the.
Port roles. The port roles we are gonna electrify these ports, DP, RP, and blocking these port roles.
I see. I mean, so we need to select which port is like a root bridge and which is not, right? Is that
Which
what you
port
say?
is a root port, which port is a designated port, which port is the alternate blocking.
Okay. So to calculate the port, to find out the port, we need a cost.
You're right. You will understand. So I'm
Okay.
assuming that this link is a 4 gig link. This link is a 4 gig link. This link is a 4 gig link. Okay. Sorry, not 4 gig link. Cost is 4. The link is a 1 gig. The link is a 1 gig. The cost is 4. You can understand anything. That's fine. Now,
Yeah, no, that's fine. No problem.
every root bridge, every port of root bridge is known as a DP port. The reason is that because of lower cost. Understood this concept. So every root bridge, every port of the root bridge is known as a DP port. So this guy will be on DP, right? Designated for ring, and this guy will be on designated for ring. Why I'm calling this guy a designated for ring? The reason is that because when the switch, understand this diagram again, right? When the root bridge is gonna send the BPDU, understand guys, please pay attention. It's very important one. Spanning tree has a lots of theory. You need to configuration is very less. Only you have to understand the theory part. When the switch 1 is going to send the BPDU packet, when the switch 1 is going to send the BPDU packet, in this BPDU packet, they will be sent lots of information like a bridge ID, root bridge information, MAC addresses. One of the another factor is a cost. So when the root bridge is going to send, the cost will be 0. Now, when the switch 2 will receive the BPDU on this particular interface, what he will do that? He's now going to add it 0 plus 4 is equal to 4. So at receiving point, right, the cost is being added. At receiving point, cost is being added. So when the switch 1 is going to send the packet, BPDU packet, in that time, the cost will be 0. When the switch 2 will receive it, it's going to add the cost on this particular interface. Now, when the switch 2 is going to forward this BPDU to the switch 3, what will be the cost now? The cost will be the 4 on this particular interface. When he will receive he will add the what? He's adding the 4. Now he will add the 4 plus 4 is 8 now. Now, when the switch 2 is going to send the BPDU to the switch port, what the cost he will send? 8. When it will receive the BPDU on this particular interface, switch port 0/0, he will add 8 plus this one is 4. It's 12. So total is 12. That's called the root path cost. So which cost you are advertising in the BPDU? you are advertising in the BPD user cost is called as a route path cost. Which cost the switch is added?
The path cost.
Path cost. This thing is clear? Okay, now. Okay, these are the very small things that you have to pay attention, guys. Yeah, I'm again repeating, spanning tree is a very easy topic. Only the thing is that it has a lot of theory. Okay, but yeah, you will eventually at the last of the day, right? After the having the 4 to 5 class, you will understand the spanning tree. Don't worry. It's right now, it's new. That's why you're not understanding. So every port is a root bridge. Every port of the root bridge is not the TP port because of the lower cost. Because when this guy is going to advertise the BPD, what will be the cost for this guy? 0. What is the cost for this guy? 0. Based port on the segment is known as a DP port. Simple language. Best port on the segment is known as a DP port. Now, your question comes in the way, what is segment? This guy is known as a one segment, a link. This guy is known as a one segment, a link. This guy is known as a one segment, a link. Right? On every segment, you will have only one DP. Only one DP you will have. So if I already selected the DP on the switch 1 because of the root bridge, because every port of the root bridge is known as a DP port because of the lower cost, right? So he will be there DP, right? Now we need to make an election of the what? RP. Let's do the RP election, right? So RP we can call as a every non-root bridge, right? Try to find the best path to reach the root bridge. So now you tell me one thing about the root port, right? If I talk with the switch 2, that's a non-root bridge. I do have a 2 path to reach the switch 1, this way or this way. Which path is the lower one? If I go through this one, the cost will be 4. If I go through this one, the cost will be 8. 4 plus 4. Which one is the lower?
4.
The 4.
Right. So automatically this interface will become the RP port. On every non-root bridge, you will only have a one RP. RP. We have done with RP on this guy. Now, switch 3 perspective. If I go to the switch 1, because we need to find the one RP on the switch 3 as well, right? So if I go to the switch 3, every non-root bridge try to find the best part to reach the root bridge. So if I go through this way and this way, which one is lower? 0/0, 0/1, 0/0, right? So 0/0 will become the RP again. So this segment has done, this segment has done. Now we need to find this segment. You tell me one thing. So we have done with the root bridge, sorry, root port, right? On every non-bridge, you will only have a one RP. Now, on this particular segment, we cannot have RP, right? We cannot have RP. The reason is that already we have RP on the non-root bridge. Already we have RP on the non-root bridge. So on this particular segment, either the port will be DP or either the port will be blocking. How we are going to decide it? Now, in this case, what happened? Once your cost will become the type, have a look over there. If the switch to will go, because already we did the selection of this particular interface, right? So I cannot go by this one. So if I go to the root bridge from this way, right? And if I go to this way, cost is same, right? See, cost is same. 4 plus 4, 8. 4 plus 4, 8. If the cost will tie, then what? Lower sender bridge ID. if your cost is tie, right? Because the first we did the lowest route bridge ID, we did it. Then we took the lower route path cost, we did it. Now the cost is tied, right, between the switch 2. If you go to the switch 1 via this way, the cost is 8. If the switch 3 will go via this way, the cost is 8. The cost is tied. Now the next was what? Lower sender bridge ID. Who has a lower sender bridge ID? So when the switch 2 is going to send the BPDU, try to understand. When the switch 2 is going to send the BPDU, what information they will put? B plus. And when the switch 3 is going to send the BPDU, what he will put? Who has a lower one?
Switch 2.
Switch 2. So switch 2, this interface will become the DP port, and this interface will become the blocking. So eventually, this is the how we are preventing the loop. So from this segment, we are not gonna send any packet. All my data traffic, right? All my data traffic, the PC1 we have, the PC2 we have. All my data traffic will go via this link. This link is a broken link. We cannot send the traffic from this link. So the logical topology for this guy will be what? If you see the logical topology for this guy, let me create the logical topology for you guys. Then you will understand more clearly. This is the physical topology. The logical topology will have switch 2, switch 3, switch 1, and switch 3. So the logical topology will be like this way. That's my logical one. Read some theory part. Not gonna dig through the other one. Just gonna give you the basic part information. Now, each non-root switch, right, must figure out the relation to the root bridge, right? So every non-root bridge is trying to find the best relation to the root bridge. Simple logic. Every employee is trying to find the best relationship with the manager. Every, like what we call, people are trying to find the best relationship with the prime minister, right? So selecting the only one root port on each non-root. These are the very important line, guys. Hello, can you hear me?
Yeah, we can hear you.
Yeah, great.
Yes, that's right.
Okay, so the most important line that you need to understand, is what? This line that I talked about, right? Every non-root bridge, right? You will have only one root port. Make a note, it's gonna help you. Why? Every non-root switch is trying to figure out the best relationship with the root bridge. Every employee is trying to find the best relationship with the manager, right? Root port comes in the picture how? Based on the root path cost. We already discussed this thing, right? And the path cost will be changed according to the bandwidth. Now, next one that we have, already we give this note on the paint file. I'm just recapping it through the book as well. DP port, designated port, right? Not this one. Yeah. Choose the DP port, right? Based on the lowest cumulative root path cost to the root bridge. A switch always has an idea of its own root path cost, which is it announced in the own BPDU. I talked about, right? When the switch 1, remember the 3-4 linear topology we have, switch 1, switch 2, switch 3, switch 4. So when the switch 1, that was the root bridge, when he gonna generate, right? When he generate the BPDU, he knows that what is my root path cost, right? So he put that root path cost in the own BPDU. So in the BPDU, what information we are exchanging? The root path cost, right? Now, and to finally, we have another type of port is what? It's a blocking port is what? The blocking, it's not given the blocking port of the theory. Okay, the final port is what? The blocking port to remove the loop from the network. So we only have a 3 port over there. If you have any question, these are the very important line. You just need to remember this part. Okay, every port on the segment is known as DP. Every best port on the segment is known as a DP because of the lower cost, right? Every port of the root bridge is not a DP port. The reason is that because when he's gonna generate the BPDU, the cost will be 0, the root path cost. When he's gonna generate the BPDU, the root path cost will be 0, right? So in this take example, in this segment, who will be a DP? Of course, this will be a DP because when he's trying to reach to the root bridge, the cost will be what? 4. But when he is trying to, this interface is trying to reach the root bridge, the cost is 0. But when he's trying to reach the root bridge, the cost is what? 4. So that's why the lower cost will become the DP1, right? Every segment has a only one DP. So this part is for the DP. I'll make this color. And this part for the every non-root bridge, you will have only one RB. And I'll make this guy a different color. I'll make this guy a yellow one. This guy and this guy's a yellow one. Every non-root bridge is trying to find the best part of the root bridge. It's a DP. Now, I haven't done the practical, I know, because I don't want to take us lots of time right now because also theory is there. We'll do the practical. Don't worry. Questions?
In this scenario, we
Yeah.
have 3 switches. One switch is root bridge.
Mhm.
So if one root bridge switch is down, other 2 switches automatically done the
We
election
will
of
do
the
the
root bridge.
election of the root bridge, right? So you don't have a backup like we have a DR and BDR in the OSPF. We don't have a such concept over here. You only have a root bridge, other will be non-bridge. So once the root bridge goes down, the election will happen for the another root bridge. Then election will happen between these two guys.
Okay, thank you.
What are the most important factors to determine the root bridge? Number one is like a priority,
So
like
first one is the priority, and the second one is the lower base MAC address. So priority get tied, right? Because of the 32768. All they have is 32768. If I'm gonna make the priority of the one, this guy, take example. Let's make it 0. And this guy's a 32768, and this guy's a 32768. So of course the priority will comes in the picture, not the MAC address. You cannot change the base, you cannot
that's
change
fine.
the base, you cannot change the base MAC address, you can only change the priority. So if I'm right now he's a root
Absolutely.
bridge, if I'm gonna make this guy the priority 0, he will become the root bridge and he will become the non-root bridge.
Okay, but that is fine in terms of selecting the root bridge and in terms of cost and bandwidth. And what else need to be checked in if the packet is going from one switch to another switch?
We need to change the
So
root path cost.
path.
One is called the path cost, another is called the root path cost. See the definition over here.
Okay, and the cost is different in every link, right?
Every link, see, you don't need to, again, I'm guys repeating that, you don't need to remember the cost for this thing, right? Nobody's gonna ask you in the interview. I'm just explaining you, right? That's all.
Sure. Okay. That's okay. No problem.
Because
That's
it's not
absolutely fine.
possible
Thank
to
you so
remember,
much.
it's not possible to remember the each cost, right? So
Yeah, it is not
cost will
possible.
vary. So even I've been the many interviews, nobody has to ask the cost, right? And it's not a possible way to remember the cost things. Yeah, sometimes if you go with the like a mini design level of an interview, then they will ask you, okay, what cost information are there in the BPDU? So in a BPDU, you will be there the root path cost, not the path cost.
Okay.
Okay, lower.
That's absolutely fine.
On this paper. I'll make this guy also.
Okay. No problem. That's fine. Just last thing, I think you sent the email yesterday, right?
I sent it.
You have sent it. Okay, no problem. That's fine. Actually, I didn't get a chance to look at it. I believe you have sent it. Okay, that's fine.
You haven't received
Okay.
yet? Okay, is one question from the smile. First of all, let me go with the smile. RP selection option is a 5. So switch will be check all the any one option is now. RP selection option is 5. What do you want to switch 5? Okay, if you have a 5 switch, you are talking what? RP selection selecting the options 5 switch will check all or any one option is now. And I didn't understand your question is ma'am. If you are talking about if you have a 5 switch in your network, yeah, election will be happen on everywhere. Is the root path is fasted? Is the root path is fasted? What do you mean there is a fasted? It's depend on the bandwidth, Keras, right? So it's depend on the bandwidth. So if you see, we have a different bandwidth. Based on the bandwidth, the cost will be changed. So lower bandwidth has a higher cost. One more question about the switch MAC address after the everyone is done. Take care. Bye, everyone. Yeah, take care, Nasim. Yeah, you can go ahead, Bidu. You can go ahead, ask a question.
So again, I'm sorry, it's been close to 2 years since I've worked on any device, and
No, sure, that's fine.
I think I must have overlooked this detail when I used to work on them. My basic understanding, and again, if you've already covered this in past lectures, I'm sorry, but my understanding was that I understand the basic MAC address on the switch, for example, for purpose of managing the switch. But as far as the switch ports were concerned, I thought, the switch simply learns the incoming, the MAC addresses from the incoming, packets of the connected devices on those switches. I for some reason don't remember the switch ports themselves having individual MAC addresses.
We have.
And I wonder if this is on like all switches, including the most basic switches, or only for
everything.
managed switches?
No, personally, I haven't seen the I haven't never checked the unmanaged one, but managed one, everyone has a interface mechanism.
Okay. Yeah, I
Even
must be
the-
forgetting. It's been
Even the router does have.
no routers, yes, because they have to. It's a
They have
layer
to
3,
because of
but
the
I didn't
upgrade.
realize that. Right. I didn't realize that every switch, because I thought all switch ports only learn the MAC addresses from the connected devices or the packets traveling through. For some reason, I just forget that they had their own MAC addresses as well. So I was like,
Every switch
okay.
interface has a MAC address, and apart from that one, to identify the switch itself has a MAC address that's known as a base MAC address.
All right. Okay. I
Can you see
wonder how
that?
that
Because the
affects.
massive. So they see the problem with the loop. So it's been 2 hours. So the maximum number of event has been reached to you may clear the event list, right? So buffer has full now. So yeah, problem is there, man. Okay, so I'll save this to paint file, guys. I'll save the paint file to you guys, not now. Once we have done with the spanning tree, because I want to make all the spanning tree stuff in a single paint file. Save it. CTP water. And all done, guys. Okay, tomorrow is the 26th January.